Now we discuss distance time graph for uniform motion. If object cover equal distance in equal interval of time is known as uniform motion. Thus, object in uniform motion, then graph between distance and time is straight line. If object cover 15-meter distance in each 10 seconds, if we draw graph with the help of given information, its nature is straight line. Now we discuss distance time graph for non-uniform motion. If object cover unequal distance in equal interval of time is known as non-uniform motion. Thus, object in non-uniform motion, then graph between distance and time is not straight line. Suppose if bus cover unequal distance in equal interval of time, the nature of graph will not be straight line. Okay, there has to be difference between distance time graph for uniform and non-uniform motion. That is, for uniform motion, distance covered is directly proportional to time, but non-uniform motion it is not. Now we discuss velocity time graph for uniform velocity. For this purpose, we discuss one more example. That is, train is moving with a uniform velocity of 60 km per hour for 5 hours. Velocity time graph for uniform motion is straight line. With the help of graph, we determine the distance covered by train between 2 to 4 hours. If we find out area of quadrilateral ABCD, then we get distance covered by train in 2 to 4 hours. Here, quadrilateral ABCD is rectangle. You find its area, that is length into breadth, that is 60 into 2, that is equal to 120 km. Okay, now we discuss velocity time graph for uniform acceleration. For this purpose, we discuss one more example. That is, a car covers equal distance in equal interval of time. Here, velocity changes equal amounts in equal time interval. Thus, it is uniformly accelerated motion. So, nature of graph in uniform accelerated motion is straight line. Suppose if we find out distance covered by car in 10th to 20 seconds, for this purpose we draw perpendicular to straight line from point C and D. Then what happens? Specific structure, that is quadrilateral, happens. Name of the quadrilateral is quadrilateral ABCD. To find out area of quadrilateral ABCD, first of all draw perpendicular to line BC from point A. Because of this, quadrilateral gets converted into triangle ABC and quadrilateral ADCE. Thus, the area of quadrilateral ABCD is equal to area of quadrilateral AECD plus area of triangle ABE. In this way, you find out area covered by car. Now, we all of us discuss equations of motion using graphical method. We all of us know that equations of motion. For this purpose, we all of us consider, let u be the initial velocity, let v be the final velocity, small t be the time period, small a be the acceleration, small s be the displacement. First equation is phi is equal to u plus at. This is relation between velocity and time, that is first and last letter. Second equation is s is equal to ut plus half at square. This is relation between displacement and time, that is first and last letter. Third equation is v square is equal to u square plus 2as. This is relation between velocity and displacement, that is first and last letter. All three equations are described with the help of velocity time graph. Because of this, we discuss velocity time graph. Okay, if object start at point D, reach at point B after time t, therefore its initial velocity u, that is OD, final velocity v, that is OC, and time period small t, that is OE. We all of us know that acceleration, that is a is equal to v minus u divided by t. It's a formula. Now we put its values, then what happens? A is equal to OC minus OD divided by small t, but OC minus OD means CD, therefore CD is equal to A into T, but phi is equal to CD plus OD. If we put that values, then phi is equal to AT plus U. Therefore, phi is equal to u plus at. In this way, first equation is proved with the help of graph. Then, second equation proof with the help of graph. For this purpose, we draw perpendicular line on OE from point B and draw perpendicular line on segment BE from U and draw perpendicular line OC from point B. To prove second equation, we all of us only find area of quadrilateral DOEB, but area of quadrilateral DOEB is equal to area of quadrilateral DOEA plus area of triangle DAB, that is S is equal to AE into OE plus half into AB into DA. If we put values, then we get S is equal to UT plus half AT into T, that is S is equal to UT plus half AT square. Now third equation proof with the help of graph. Here only find out area of quadrilateral DOEB directly. Third equation of motion obtain. S means area of trapezium DOEB, that is S is equal to half into sum of length of parallel sides into distance between the parallel sides. If we put up values, we get S is equal to half into U plus V into T, but we know that A is equal to V minus U divided by T, therefore T is equal to V minus U divided by A. Substitute this in above equation, we get S is equal to half into U plus V into V minus U divided by A. Therefore S is equal to V plus U, another bracket, V minus U divided by 2A. Cross multiply, then what happens? 2as is equal to V plus U, another bracket, V minus U, that is 2as is equal to V square minus U square, that is V square is equal to U square plus 2as. In this way we prove third equation with the help of graph. Okay.